All right, so as a reminder, molecular compounds are made up of two nonmetals. And they're held together by a covalent bond. Okay, so what a covalent bond means is that the electrons are being shared. Now, as said previously, there are two types of covalent bonds. One is polar covalent and one is nonpolar covalent. Polar covalent means that the electrons are not shared equally between the two atoms, whereas nonpolar covalent just means that the electrons are being shared equally between two atoms. Okay, so why do the electrons need to be shared between the two nonmetals? So since molecular compounds contain only nonmetals and these all have negative charges, all the atoms in the compound want to gain electrons. Okay, so most molecular compounds tend to have a relatively low melting and boiling point, and many exist as gases or liquids at room temperature. With molecular elements, they're elements which bond to themselves by way of covalent bond to form a molecule. Okay. So, with molecular elements, there's two types. There's the diatomic elements. So this means whenever these elements are by themselves, not in a compound, they exist with two atoms kind of grouped together. So how I remember this is Hofbrinkel. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. So those are all of your diatomic elements that exist. Okay. Now we also have polyatomic elements. Okay, so poly just means many. So in other words, more than two. So essentially these are going to be your elements that when they are by themselves, not in a compound, there's more than two atoms grouped together of this element. So ozone is an example, elemental sulfur, and elemental phosphorus. Those are your three polyatomic elements. And again, polyatomic and diatomic elements only exist like how I've shown here, when they are by themselves and not in a compound. Okay, that's going to be very crucial for when we are creating molecular compounds. Okay, so rules for naming and writing formulas for molecular compounds. So all of this is going to be pretty important information. So let's highlight this box. So step number 1, binary molecular compounds. So binary just means you got two elements in this compound name if you're talking about a binary molecular compound. And they're named using prefixes. To indicate the number of each atom, since we can't rely on the charges like we could in ionic compounds to tell us how many of each element that we needed. Okay, so the prefixes, those are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, so the subscript after each element is going to tell you how many of the atom that you have. Okay, so with these prefixes, you are going to have to memorize them. They will not be given to you. Step number 2, if there are only 2 elements in the molecule, then the first element, which is the more quote-unquote metallic of the 2, even though it's a nonmetal, is named using its regular name. So important, the prefix mono is usually dropped off the first element in the compound. So if you only have one of whatever element comes first in your compound, you typically won't name it as mono, whatever that element is, and then the name for the second element. Okay? You'll just name it the element name. For step 3, the second element, or the least quote-unquote metallic, even though it's still a nonmetal, has its ending changed to IDE. So it doesn't mean it's an ion, it just means that the compound is binary. So there's 2 elements in that compound. So for example, we have Ni3. So because we only have 1 nitrogen, okay, the prefix that means 1 would be mono. However, since it's the first element of this compound, we do not write the mono prefix, we just write nitrogen. Okay, and then for the second element in this molecular compound, there's 3 iodines. So I'm going to write tri, because that means 3. Triiodide. And reminder, we can't write triiodine, that INE ending. We have to change that ending to IDE. So molecular compounds, for binary compounds, they will always end with the IDE ending. Okay, P2O5. Well, P is phosphorus. Okay, very important that you know that P is phosphorus. It is not potassium. Potassium is K. Okay, now we want to say, okay, there's 2 phosphorus atoms. Okay, so I'm going to write di, phosphorus. So just a note here, if the prefix is mono on the first element, you don't write it, but any other prefix for the first element in a molecular compound, you will write the prefix. Okay, and since we have 5 oxygens, okay, so the prefix that means 5 is penta, so I'm going to write pentaoxide or pentoxide. Typically, you go with the spelling that kind of rolls off your tongue a bit more easier. Okay. Now, if you wrote pentaoxide, would I dock marks? No, but I'd be writing this as pentoxide. Okay. For this next compound, we have 4 sulfur atoms and then 2 nitrogen atoms. So we have our prefix, that means 4, so that's going to be tetra. So tetra sulfur. And then di, and then nitrogen, but we have to change the ending to IDE, so dinitride. Okay. Moving on to going from a name to the formula. First one here is sulfur dioxide. So there's no prefix to the sulfur. That means there's only one of them. So I'm going to write sulfur and then di. That's a prefix that means 2. So O2. Carbon, there's no prefix. So there's one of them. Monoxide, well, mono is a prefix that means 1. So there's only 1 oxygen. So carbon monoxide. For the last one, dinitrogen. Well, di means 2. Nitrogen, so N2. Then monoxide, it's going to be 1 oxygen because mono means 1. All right, and as always in chemistry, there are exceptions. So exceptions to naming molecular compounds. Okay, so the first atom, as we've discussed previously, does not get the mono prefix. So for example, CO2, that's going to be carbon dioxide, so di because there's two oxygens. Okay, but it's not going to be monocarbon dioxide. Okay. Additionally, hydrogen compounds, those are unique, and they're not named with the prefix system. Okay, so for example, H2S is hydrogen sulfide. Not dihydrogen monosulfide. Okay, so again, because this compound contains hydrogen, we do not use the prefix system. Now, with some molecular compounds, they have common names, and because of that, they don't follow a rule. So with the naming system we have used previously for both molecular compounds and ionic compounds, that follows something called the IUPAC naming system. However, common names do not follow that. So these specific compounds, you do have to memorize the names of them, the common names that is. So C6H12O6, that's glucose. You may recognize this from your biology class, whether you're in Bio 20, Bio 30, or maybe you recognize it from the biology unit in Science 10. C12H22O11, that is sucrose. CH3OH, that is methanol. So this uses a naming system that will be covered in Chemistry 30. C2H5OH, that is ethanol. NH3 is ammonia. CH4 is methane. C3H8 is propane. H2O2, hydrogen peroxide. H2O, good old water. Okay. So all of these you will have to memorize. The ones that often get used in Chemistry 20 would probably be glucose, methanol, ethanol, ammonia, hydrogen peroxide, and water. Those ones are probably more used out of the whole list that we have been given. Okay, but you should know all of them. All right, so as a summary, ionic versus molecular compounds. So how do you distinguish the two? So we'll start off in the top left-hand corner here. Okay, is the first atom a metal or a cation, being ammonium? So NH4 1+. So a reminder that this ion, because it is a cation, so it has a positive charge, it acts like a metal. Okay, so if the first atom is a metal or NH4, or you could even say, like, if the first atom is a cation, then it's going to be an ionic compound. Okay. Now, if the first atom is not a metal, or NH4 1+, okay, then you got to ask yourself if the first atom is a nonmetal, and if yes, then it's going to be a molecular compound. So with ionic compounds, there's 4 different types of ionic compounds. There's binary, so that just means that there's 2 different elements in the same compound. A reminder, because this is an ionic compound, one will be a metal, one will be a nonmetal. With polyatomic, that means that there's 3 or more different elements. Ionic hydrates, I skipped over that because that is an AP or an IB topic. So for regular chemistry 20, you do not need to know ionic hydrates. Number 4 is multivalent. So remember, those are metals that have more than one possible charge. So these metals that have more than one possible charge, you're going to find them in the transition elements, or the transition metals. Both names can be used for that section of the periodic table. Okay, and then one last reminder here is you use Roman numerals to denote charge or to represent charge. Not how many atoms of that metal there are. So that's very critical. That's a common misconception.